The secrets of the small shafts of the Great Pyramid. 5 underbar exploration robots in the Great Pyramid Part 1. At the beginning of the 1990s, the era of exploration, robots began in the Great Pyramid. It all started with a robot developed by Rudolf Gantenbrink. The engineer Gantenbrink became interested in the Giza pyramids in 1987. In 1989, he began a computer analysis of the pyramids in search of telltale traces left behind by the pyramid builders. In the same year, he established contact with Professor Dr. Rainer Stadelmann, the then head of the German Archaeological Institute DAI in Cairo. In 1990, Stadelmann visited Gantenbrink in Munich, who showed him the results of his computer analysis. Encouraged by his interest, Gantenbrink visited Cairo in 1991 and saw the pyramids of Giza for himself. After seeing what damage the daily influx of tourists could do to the pyramids, every person who entered the pyramids left behind about 20 milliliter of water sweat, which was 80% humidity at almost 60 degrees C in the pyramid. He decided to do something about it. So he contacted Stadelmann while he was still in Cairo to suggest using a robot to examine the air shafts. Stadelmann was impressed by Gantenbrink's idea and suggested a joint venture project. While Gantenbrink was working on his first robot, Stadelmann took care of the necessary permits in Egypt. So in January 1992 he received permission from Zahi Hawass, the chief inspector of the Giza Plateau, to climb the Great Pyramid together with an Egyptian inspector in order to find the opening of the south shaft of the King's Chamber, which had been forgotten for over 50 years. On his first descent of the pyramid, he promptly found the opening of the south shaft. At another meeting between Gantenbrink and Stadelmann, it emerged that the latter had inadvertently promised the Egyptian Antiquities Administration a ventilation system for the Great Pyramid in order to obtain the necessary permits for the shaft explorations. Gantenbrink then assured him that it would be no problem to reconcile this with the project and even promised to look for sponsors. The Upyout 1 robot, built by Rudolf Gantenbrink, weighed 1.5 kg, was 49 cm long, 9.5 cm wide and 9 cm high. It had no drive of its own, but had to be pulled through the shaft using a winch. The robot had a camera and a laser rod on board in order to be able to precisely measure the height and width of the shafts. In addition, it was only designed to examine the air shafts of the King's Chamber. In March 1992 the time had come. The first robot built by Gantenbrink, which did not yet have a name, only progressed 9 meters into the Queen Chamber shafts. This prompted Gantenbrink to modify the robot. Stadelmann suggested the name Upyout for the new variant. The robot's name was not chosen by chance, as Upyout was a god who was considered a door opener or pathfinder by the ancient Egyptians. The name should say it all. Gantenbrink returned to Cairo with Upyout 1 in May 1992. First, however, the upper north shaft of the King's Chamber had to be cleared of rubble and rubbish. There was a good 5 cubic meter of civilized waste in it. The next step was to install a ventilation system using fans, which were installed in the lower area of the royal chamber shafts. Just 1 day later, the humidity in the King's Chamber had fallen from around 79% to 53% 58, which corresponded to the value outside the pyramid, and then remained there at 30% of the maximum fan capacity. This helped prevent further damage from excessive humidity inside the pyramid. Back in Munich, Gantenbrink set to work developing a significantly improved robot model, Upyout 2, which worked together with a rope climber support vehicle, which he also developed. At 6 kilograms, Upyout 2 weighed 4 times as much as Upyout 1. It was equipped with a laser guidance system, a Sony CCD miniature video camera with pan and tilt capabilities. 7 independent electric motors provided propulsion. At full traction it could exert 40 kp of pulling force. Upyout 2 was 37 centimeters long, 12 centimeters wide and could adjust its height from 12 to 28 centimeters. This meant he was able to touch the bottom and ceiling of the shaft at the same time for optimal traction. Regarding the precision of the distance measurement of Uppyaut 2, I would like to briefly quote Rudolf Gantenbrink. For the measurement of the lower shafts, Uppyaut 2 was equipped with a special cable specially manufactured by the company Gore-Tex, which was calibrated had measurement markings. The measurement was taken between a laser point thrown onto the ground and the relevant marking on the cable. The markings on the cable were placed at 1 meter intervals. Intermediate measurements were determined using the folding ruler to the next mark. The cable not only had a special, low-friction jacket, but also a core made of untwisted glass fibers with a breaking load of around 200 kilograms. A possible elongation due to tension at 60 meters is in the range of less than 1 centimeter with a tensile force of 200 kilograms. Taking into account all possible imponderables, slight snaking of the cable in the lower low-tension area, slight kinks in the shaft, etc., a deviation of at most ±5 centimeters can be assumed. In 1993 we were able to determine the total length of the southern shaft of the Queen's Chamber to be 59.45 meters. In March 1993, Uppyaut 2 was deployed for the first time in the north shaft of the Queen's Chamber. However, it only pushed 19 meters into the shaft. Because at the first 45 degrees bend in the shaft, metal bars blocked the robot's further path. The robot was then sent into the south shaft, where it progressed 53 meters before a 4-5 centimeters step prevented it from continuing. After several days of intensive tinkering, Uppyaut 2 finally managed to overcome this obstacle on March 22, 1993, and at 11:05 am it reached a blocking stone, the door, with 2 metal pins that made further exploration impossible. The blocking stone was a minor sensation for Egyptologists, especially because it contained 2 metal pins. Stadelmann suspected that the objects he described as copper pens might be hieroglyphs.